All right, today we're going to be going over some review notes from 8.1 to 8.3. If you would pull out your red pens, we're going to fill in this section of important information. So on your quiz and tests, there's going to be a vocab section, and there's quite a few words that we've covered in these three sections. So let's see if we can figure out the very first one. The first one says a blank is an entire group of people or objects. What do you guys think that is? A population. So for that first one, use your red pens and let's fill in population. All right, the next one kind of goes with that. A blank is a part of a population. Sample. Good job, guys. Then we talked about two different kinds of samples. Do you guys remember what they were?
No.
Unbiased and biased. Very good. The first one we're going to put in here is an unbiased sample is representative of a population. What two things does it have to be unbiased?
Random and then...
Very good. Large and random. All right, so the opposite of unbiased would be biased, okay? Biased samples are not representative of a population because, do you guys remember this? One or more parts are favored.
I said favorable. That's like the same thing, right?
All right, then we started talking about different data sets. What's another name for the average of a data set?
Median.
Not the median.
Shut up. It starts with a V, right?
It starts with an M. What is it, guys?
Mean.
It is the mean, okay? Another name for average is the mean. Now we just went over this one. The middle number is the median. Okay, we've also called that the center. All right, does anyone know the answer to the next one? What do you think?
Quartile.
Not quartile, but range. Okay, the range is the difference between the highest and the lowest numbers in a data set. Then we've talked about the next one. A box and whisker plot is, I want you to write this in there, skewed when one whisker appears way what than the other? Not larger, but longer. Okay, so you want to make sure you know and understand this important information for your quiz coming up on Monday and your test on Wednesday. All right, so just a minute ago we were talking about determining if something is biased or unbiased. Here's the situation for number one. You want to estimate the number of students in a high school who ride a bus to school. You ask 50 high school students during their outdoor school activity. So they have an outdoor activity afterward. All the high schoolers come to it. So we can see they're asking 50 people and they're asking them at the outdoor activity. What do you think? Is that biased or unbiased?
Unbiased.
It is unbiased. How can you tell when something is unbiased?
Large and random.
As we just said, it is large and random. For this, once again, they asked 50 people and they randomly were asking them when they were outside at this activity. All right, let's try another one. You want to estimate the number of people in Jacksonville who enjoy shopping at the St. John's Town Center. How many of you have been to the St. John's Town Center before? Okay, so they're trying to gather this information. So they go and they survey 20 people in Miami. What do you think, biased or unbiased? That is definitely biased. Who is it favoring? The people in Miami. Do you think people in Miami care much about the St. John's Town Center? No, probably not. They've probably never even been to the St. John's Town Center. So that's definitely a biased opinion because they probably have never been there. Now moving on, we're going to talk about whether something is valid or not valid. Valid means truthful. Not valid means not truthful. Number 3 says you want to determine the number of students in your school who have been to see a movie at an Epic Theater. Raise your hand if you've ever been to the Epic Movie Theater, okay? I know there's AMC, there's different kinds, but this one is specifically talking about those who have been to the Epic Movie Theater. You survey 40 students at random. Okay, so we can see this is a good sample. It's large and random. 35 have been to an Epic Theater and 5 have not. You conclude that 15% of the students in your school have not seen a movie at Epic. I want you to take your pencil and underline students in your school have not seen a movie at Epic. That's what I'm trying to focus on right now. So when I do this, if you remember, we are writing or figuring out what part we're looking for divided by the whole amount. What part did they conclude of students that have not been to an Epic Theater?
35.
No, we're looking, what we underlined, have not seen a movie. Only 5 of them. Out of how many?
35. I mean 40.
Which one is it?
40.
40. There were total students that were surveyed at random. What's 5 divided by 40?
1/8.
It is 1/8. What would that be as a decimal?
8.8.
You got to do 1 divided by 8 or 5 divided by 40.
What? 1.25.
0.125. Now we want to turn that into a percent. What would that be as a percent?
12.5.
Okay, 12.5 or 12.5%. So let's go back to see what conclusion they come up with. They said you conclude that 15% of the students in your school have not seen a movie at Epic. So is the answer we came up with, was that a truthful answer or not truthful? It's not truthful, okay? It's close, but it was only 12.5%, not 15. So is this valid or not valid? It is not valid. I want you guys to do number 4 on your own and see if it's valid or not valid. Okay, so here's what happens on this one. You want to determine how many people like the pizza in the lunchroom. You survey 75 people at random coming out of chapel. Was that a large sample? Was it random? Okay, so this is a good sample. 60 of them say that they do like it, and 15 say they do not like it. You conclude that 80% of the people you asked do like the pizza. So I'm focusing on how many like the pizza. How many people did you figure out liked the pizza?
80.
60 out of how many? 75. And what was that as a percentage?
80%.
80%. Is that what it says to us?
Yes.
Yes. So as I go back up here, it says you conclude that 80% of the people like it. So is this valid or not valid?
Valid.
It is valid because that is a true statement. In fact, 80% do like the pizza in the lunchroom. All right, number 5, which sample is better for making an estimate? You are estimating the number of families in your town with 1 or more children. I want you guys to read A and B and then circle which one you think would be better. Sample A says a random sample of 10 families living near your home. Okay, so this is what that's a little bit different. And the other one is a random sample of 10 families living in your town. What do you think, A or B?
B.
B. Why would B be a better option than A?
Because the people near your home might like the kids better.
Okay? People living near your home, probably since I have kids, I want to be moving into a neighborhood that's kid-friendly, okay? So those people obviously are probably going to have more children than maybe someone else who lives in a different community without children. So in order for it to be unbiased or not favor a certain group of people, you have to make sure to go to 10 different families around the town instead of just near your home. Let's move on to number 6. You and 4 friends want to know how many students in your school prefer country music. Okay, so we did one like this earlier in the week. Do you guys remember what music we were looking at then? Pop. We were looking at pop music, okay? So now we're focusing on those who like country music instead. There are 900 students in your school, and each person in the group randomly surveys 30 students. The table shows the results. Because we are focusing right now just on those who like country music, I want everybody to circle just the country music section of this graph. In your notes to the right of the box, I want you to write this formula. Favorable divided by total equals n divided by the population. All right, so let's use that formula to help us figure out what the mean number of students in our school are that prefer country music. Starting with you. How many people did you identify liked country music the best?
10.
10. Out of how many people did you ask?
30.
10 out of 30 equals n over, what's the population of students in your school? 900. So the easiest way to do a problem like this is to figure out what the missing link is in the mental math problem. So I'm trying to get what n would be. I have to figure out how to get from a 10 to an n, which means I have to figure out how to get from a 30 to a 900. Rome, what's the missing link? Remember, to find the missing link, you just take the bigger number and divide by the smaller number. 30, okay? So I'm going to have to multiply by 30 to get over there, which means at the top, I also need to multiply the numerator, 10 times 30. Guys, what is n?
300.
300. Now I'm going to take that and put it over here in the box because we are estimating that about 300 students in your school are going to prefer country music. Now let's go on to friend A. Emma, how many people did friend A discover liked country music? 2 out of how many did they ask?
900.
No, they didn't ask all 900. They asked 30. 2 out of 30 equals n over, what's the population? 900. Okay, so the cool thing about this, once again, is my missing link is going to be the same because I'm just trying to figure out how to get from a 30 to a 900. So guys, what's the missing link?
30.
30. I'm multiplying by 30 on the top and the bottom. Emma, what do I get?
60.
60 is correct. I'm going to put that over there for friend A. Who would like to do friend B? Thomas. So how many did friend B like country? Okay, so 8 out of 30 equals n over the population. You know the missing link, and once again, you're multiplying the top by 30, and he told us he figured out the answer was 240 students. What do you recognize about friend C?
It's the same thing.
As?
Friend B.
It is the same thing as friend B. There is no need to do all of that work. You're just going to say same as B, and over there, put 240 in the box. We have one last friend left, Miley.
Put 15 over 30, and then n over population, which is 900, and then the missing link is 30.
Okay, so we multiply the bottom and the top by the missing link of 30, and then you get
450.
450. For problem A, it says use the sample to make one estimate. So I don't want all of these different numbers right here. I only want one estimate to find the mean number of students in my school that prefer country music. The first thing I have to do is put all of these numbers in order from least to greatest. So we've got 60. If you would, stick that directly underneath where it says U, that box. And underneath friend A, we'll put 240. 240 again. What's the next one, guys? 300, and then finally 450. In order to find the mean, what do I have to do to those numbers?
Add them all.
I have to add them all up. I want you guys to add those for me, please. AJ, when you add those together, what do you get?
1,290.
1,290. Is that my mean?
No.
No. What do I have to do?
Divide it by 5.
Divide it by 5. Why by the number 5?
Because that's how many people surveyed different.
Okay, looking right here, there were 5 numbers that I just added together. Okay, so we were adding those 5. We divide by 5. And what's the answer?
258
Okay, 258 what?
students.
Students. Always make sure you attach the units to the end. Okay, so I have my information over here and all the numbers are in order from least to greatest. Problem B says use the sample to describe the variation of the estimates. We are looking for the center or the median. Which one of those numbers is in the center? 240. Everybody circle that for me, please. All right, so that's my answer right there, 240 students. Next up, we have the variation or the range. How do I find the range when I have data like this? You are correct. You take the biggest number, which is 450, and you subtract the smallest number, which was 60. And this tells you the range of students. How many students would that be?
390 students.
390 students. Okay, so that's how you find the center and the variation when using the information that you got from the mean of your data. All right, number 7. An administrator randomly asks 48 middle school students if they are in favor of the new dress code. 12 of them say they are. There are 900 middle school students at the school. Estimate the number of students in the school who are in favor of the new dress code. What formula do you think I'm using for this? Favorable divided by the total equals n divided by the population. I want you guys to try to plug in those numbers and then stand once you think you have the answer. Okay, in order to find what favorable is, it's what you're looking for. Okay, so what is it, how many of them said that they are in favor of the new dress code? 12 of them. Out of how many total? 48. Equals n divided by the population, which was 900. Did anybody use the mental math method? Okay. In order to find the mental math method, you're just taking the bigger number, 900, and dividing by the smaller number, 48. What's the missing link?
18.75.
Okay, so I can multiply it by 18.75. How many of you would say that you chose to do cross products? All right, let's see if we get the same answer. 48 times 18.75 is 900. What is 12 times 18.75? 225. And then units attached would be? Students. If you did cross products, how many of you would say you got the same thing? Okay, excellent. Any questions about this one? Number 8 says you want to know the mean or the average number of hours that students in the band practice each week. 5 students were asked at each school, and 4 schools are represented. So at the very first school, A, you can see here, that's the number of hours that they practiced each week. In order to find the mean, what do you think I need to do to those numbers? I need to add them all up. When I add those up, Hayden, how many hours total did they practice? 55 is correct. Now we're trying to find the mean, so I'm going to divide that by how many students they asked. Miley, how many students did they ask at school A?
5.
They asked 5. Ariana, what is 55 divided by 5? 11 is correct. So now I'm going to put 11 down there where it says sample A mean. Let's go on to problem B. This is a second school, and you can see we're going to focus on that I just highlighted right there in the red. Hope, when you add up all of those hours, how many hours did school B practice total? 50. Divided by, they asked how many students, class? 5. Emma, what is 50 divided by 5? 10 is correct. Then I write that down there. I want you guys to do C and D on your own. Okay, let's see what you got. C, how many hours total? 45 divided by 5 is 9. Very good. Problem D, how many hours total? 55 divided by equals 11. Now, I need to have one mean for all of this data. How would I do that? Add up each of them. So I'm going to add 11, 10, 9, and 11 again. When you do that, what do you get? 41. Is that my answer?
No.
Divide it by?
4.
4, because that information came from 4 different schools. Does this ask me to give a nice rounded whole number? No. So you're just going to tell me what the answer is. What would it be? 10.25. 10.25 what? Not students. You cannot have a fourth of a student. Hours. Okay. Always go back and see what it's asking. If you look up here, it says you want to know the mean number of hours. So that's going to be the units you want to put for that problem. All right, the final 4 questions are about this double box and whisker plot. I want you to answer 9 through 12 on your own. Okay, let's see what you got. Question number 9, what are the measures of center? What's another name for measure of center?
Median.
The median. Rodney, what's the measure of center for data set A? 7 is correct, all right? That's the number that comes in the middle. Rome, what about data set B? 8, very good. Once again, the number that comes in the middle, or the median. Moving on to the measures of variation. What's another word for variation? The IQR, the interquartile range, okay? So we are focusing on the right side of the box minus the left side of the box, which is my upper quartile minus the lower quartile. So looking at data A, you should have, first off, found 9 minus what number? Minus 5. What is 9 minus 5? 4. So the variation for data set A would be 4. AJ, what'd you get for data set B?
11 minus 7, and that equals 4.
And that also equals 4. Good job, because remember, once again, all you're doing is you are taking the upper quartile and subtracting the lower quartile, and that helps you to find the IQR or the variation. How many of you got both of those correct? All right, final 2 questions. Which data set is more likely to have a value of 10? Raise your hand if you said data A. Who said data B? Data B is correct. Notice right here, if this is where the 10 is, and I want to figure out which box I would land in data set B. Next one, what did you get? Raise your hand if you got A. Raise your hand if you got B. All right, we're like 50-50 on this one, okay? So let's see which one we should have gotten. Which data set is more likely to contain a value that differs from the center? Once again, it's different from the center by how many?
3.
By 3. So what is the center for shelter A? 7. That's the center. If I were to say it differs by 3 more, what is 3 more than 7? 10. Notice that's on the whisker. It's not in the box. And I don't want it to be on the whisker. I want it to be in the box. What about 3 less than 7? What would that be? 4. Is that in the box? No, so I know it's not going to be shelter A. Let's try shelter B. What's the center?
8.
8. What is 3 more than 8?
11.
Is that in the box?
Yes.
So what should my answer be? It should be data set B. All right, so be sure to study these notes to help you for your quiz on Monday.